Hello everyone, welcome to Learn Overflow. In this video, we'll discuss about another LeetCode problem, that is the out of boundary paths. We'll understand what this problem is all about and how we can think of finding a solution to this kind of problem. And ultimately, we'll see how we can optimize this problem to our maximum possible optimization. Okay, so this is a medium level problem, and we'll start with going through the problem, and ultimately we'll find a solution to this. So before moving on, make sure to subscribe to this channel for regular LeetCode videos like this. It says like there are m cross in grid with a ball, like there's a ball in a m cross in grid, and the ball is initially placed as position the start row and the start column. So this is the start row and start column given to us. This is the position of the ball that's given to us. Okay. Now it says that you are allowed to move the ball to one of the four adjacent cells in the grid. So we can move the ball to any of the four adjacent cell of the grid and possibly out of the grid crossing the grid boundary. Okay, so our target is to just move the ball out of the grid, crossing the grid boundary. So it should go out of the grid boundary. Okay, so we can apply at most max move moves to the ball. So max move is something given to us. You can see. So we can apply at most max move to our ball and find a solution to that. So that's what we are supposed to do with this. Okay. So further it says the given aim and max move, start row, start column. So these are the five things given to us. Fine. So there you can see the five things given to our function. We need to return the number of paths to move the ball out of the grid boundary. So you need to see the total number of paths we can find out to move the ball out of this grid boundary. We will understand more than that. Also, it says the answer can be very large. So return a modulo 10 to the power of 9 plus 7. Okay, fine. So let's see what it means by it. So initially the input say m is 2, n is 2. So that's a 2 cross 2 grid, and then the max move is 2. So we can have a maximum of 2 moves. And then it says the start row is 0, 0, and the 0, 0 is the starting position for us. Okay, so we need to find the maximum number of moves the ball, like return the number of moves the ball to move the ball out of the grid. Okay, so let's see the number of moves we can find. First thing they say, like it can directly go out in top, it can directly go out in left. So it is like two moves with one move at a time. If we take one move, it will we can find like there are like two ways possible. Okay, now like there are like two paths possible. Now we can, if we have a max move being 2, so we can go with two moves as well. So if we go ahead with two moves, we can find that we can go down and then go towards left, or we can go down twice, or we can go right and then top to like two moves, and then or you can go to right twice. Okay, so that's two moves. So this is more or less the question, understanding we get out of here. Okay, so it's more like we have an grid for us. Fine, we have a grid, and in that grid our ball can be at any place, right? So it's not like we need to go ahead and check all the paths. Okay, say you may say like why it went if it can go down and move left, then why it went down and doesn't move right, like why it doesn't take this path. The main reason being it doesn't go right just because we have like maximum two moves, and we can get down is one move, and then moving right is two moves, or two moves in done, but our ball is not out of the grid. So our target is move the ball out of the grid, right? So our ball is not going out of the grid, so we need to see that that is the condition we get over here. So we cannot go right, so we can see that that's not possible. Basically we need to go out of the grid, but it may happen that we if your move has been a bit more like two, or rather than two, if the number of moves is 3, then you can go ahead with one in the down and two in the right, and then we can go to one in the right or a one in the down. That's being our 3 moves we can calculate, like after calculating 2. So we need to think, remember something. The max move is basically the max at most maximum move. So what we need to count, one, we need to count all the moves starting from one move, then two moves, then 3 moves, till going on max move being till we reach our maximum number of moves. So we need to find all the ways to reach the point. Okay, or rather reach out of the boundary. And with first we need to see with one move, or we then need to see two moves, and in this process we will gradually see the max number of moves we can take. Okay, so it's basically sees let's take another example. Say our ball is over here 5, our ball is over here, and if it says max move is one, fine. If it says max move is one, how many ways we can actually move the ball out of the boundary? See, we cannot do it in any way. If by one move we can go over here, okay, by one move we can go over here. See, like one move we are not going out of the boundary, we are just going somehow somewhere in the grid as well, so we are not going out of the boundary, right? So that's our like one move is going ahead with. In case our max move is two, what we'll see, we'll first see by one move where we are going. By one move, we find that we are going only to these places, right? Only to these places where we're landing with one move. So we are not going out of the boundary in one move. So we'll now check for two moves, okay? Because that's the at most value we have. So by two moves, we see that we can go out in this like one and then two, fine, and then three, and then four. So we can find there are like four ways. Can we have more? Like after this move, can we, if we go to this move, like if we take a path from here to here, say from here to here, that will be a second move. But can we move out of the grid in any way? No, we cannot, right? So we cannot go ahead. So by max move of two in our grid like this, we can go move out of the grid in this four ways. Okay. Say our max move is three, so first we'll check for one move, how many ways we can go out of the grid. We find that there's no way. Then we go for two moves, and then we find that we can go out of the grid in like four ways by like by two moves. Okay. Now by three moves, can we go out? Let's say. Let's say like it we by one move we came to this, by another move we came over here, and by third move we can actually move out. Fine, by third move we can actually move out. So say like see, by third move we are moving out, or we are like coming over here, and by second move we are going to this place, and by third move we are going out. It's our choice which path we want to check, we want to take. Okay, so there are like multiple paths possible, so we need to find what, we need to find all the paths. See, in this kind of situation, what will happen, we need to see how many paths like we will keep on traversing all the times, and we'll find like huge number of solution, right? So we need to why I'm saying so, say we just take a path like this, we just take a path like this and then this. Okay, so that's one path. So we are following again this path, or this and this two path. Okay, and then we are following a path like one, two, and three. Okay, and then if I like one, two, and three, so there are like, we can see there are four paths possible. Fine. Like if we're taking three steps by one change, we are finding four paths. Again, we will find the similar step with this. The four paths will be possible from here. Four paths will be possible from here. Again, the same will be possible from here. So what we need to do with over here, see, we cannot go on finding all the paths. So we can do that, we definitely can do that. So what basically the first step we can do is just keep on traversing with decreasing the maximum, and just moving the start row column to under different positions. Okay, say it is like, if I just say it like I and J, just consider the start row and start column being I and J. So what we can do is we can go ahead with I minus one, I plus one, and J minus one, J plus one, like four different paths. We can keep on counting all the paths from there. So if we go ahead with that kind of solution, like recursively call find path and reduce, like change this row column and reduce this max move on each step. Fine. If we do that, what we find, we'll find that we're doing same path, like the same path being this one, and this one, with the same path we're traversing again and again for two moves, right? But if we note it down that okay, we from this particular box, from this corner box, if you have three moves, our moves number is three, or like our moves number is three, then from this particular box we can have at most two moves. The moves can be, one is down, one is right. Okay, so that's the two moves we can find. So for every time we come across this one move and we move to this box, we can find that there are two, a value being stored over there, and we can use that value. Like I'm thinking of more of a DP kind of solution, so that we can utilize our value being calculated previously. Fine. From this particular box, if our value is calculated previously, we're just kind of storing that value. So that's our idea over here. Okay. Now, if you look carefully, what will happen? See, what will happen? You need to have a like the first idea we said was something like I'll just write some code to just give you an idea of what the first idea was all about. See over here, I just write a small code, but to help us understand. So I just changed few things means the start move and like the start, like those values were given, right? The start row and the start column values were given to us. So I just changed it to IJ for faster typing. And I didn't show you the typing, but the look here, what I'm trying to understand, make you understand is like I'll just change this next move to this capital N. Okay, fine. Now see what this particular code is all about. Here, I'm just checking for the best case, like if we are reaching that out of the box, it's like I is aim or j is in or I less than zero, j less than zero. It's like where we are moving out of the box. Okay, so like out of the grid. So that's the out of the grid. So we find one path out of it. Okay, if we are doing anything like that, so it's like one path is there. And then if n is zero, like once our max moves become zero, that means we found out like our result is gone and now we can return from our value. But how are exactly the function will work? It will simply go ahead with we reduce n minus one, right? At each position, we reduce the number of moves and then we find how many paths are there. Okay, fine. So we just go ahead in four directions. Say we just if we just take this kind of box over here, okay, like your 2x2 box. See, we have a 2x2 box and our goal is like this. So right now our max goal is two. Okay, so if our max goal is two, we just reduce it to one. So n is right now one. Reduce it to one. So n is one. We are passing one into it, and we are just moving. See, I minus one j. So I minus one j is we are moving up. Uh, at this particular j value, we are moving the like I stores the all the row. These things are I, right, and all the columns are these things are stored by j. Fine. So all the columns. So if we're keeping a j being same and we're moving I minus one, so we are moving top. So that's I minus one j, and we're finding how many ways. So we'll find that this thing goes out, right? Like I less than zero may happen, so we return one. We'll find one way. We'll then do I plus one j. I plus one is something like, see, I plus one is going sorry, not here. I plus one is going down, and we are keeping the same j. So we find no way out of here, fine. So we'll go into this path later. Now then we find that I j minus one, keeping I same, and we're going j minus one is like going out over here, and then we are going like the other way is like I j plus one, I and j plus one will be like going to this position. So for this two position, we need to check back. But for this to pass this path and this path, we find that the base case satisfies. Okay, so we'll find that the value is one over here. Fine. For after that, what will happen? We can go ahead with other paths, like we will not can we will go ahead with the other paths. Now we'll go ahead for say we are at this position, fine, and we will do again this four things being we will simply go say I minus one j. I'll just use different color for better understanding. Yeah, so we'll do from this path we'll do I minus one j, and we'll reach to our initial position. Okay, then we'll find that n becomes zero, so we'll return zero. And like see, we are like repeating our steps before here. Okay, then will again do I plus one j. We'll come over here, we'll find a value one. Then we'll find I j minus one. We'll go out of the loop and we find a value one. And we'll find I like I j plus one. We'll go over here, and this will be like n becomes zero, and we'll return zero from here. Fine. So we are finding four ways out of here, and then we'll again start with this position. For this position, we'll go I minus one j. That will be the value one, and then we'll go I plus one j. Will reach over here, and this best case will happen. And then after that, we'll go I j minus one. Will bring us back to this position. Okay, so we are just repeating our steps. You can understand, like we are coming back to this position for knowing that this is already this is already visited by us, or this is already known to us. Okay, we know the values to this, and further we'll go to ij plus one. Ij plus one will return us one. So 1 2 3 4, and this 1 and 2. Fine. So this 6 will be our value. That's what you can see as a 6 being the value over here. Fine. So this is a solution, and this will definitely work. If I just run with this simple cases, you can find that this should work for us. Yes, this is accepted. But if you kind of submit the solution, this may give you a time limit exception. Why it may give you a time limit exception? Because look at the time complexity over here. The time complexity being look at the time complexity. The time complexity being you are like for each n, you are having 4 paths, right? So it's more like the for max move. If it's a bigger value, just think of the time complexity. It will be something like 4 to the power n, because for each n value you are having 4 different paths, right? So that will be increasing our time complexity. But how? But we don't have any way, right? We need to go to all the 4 paths to check it. But we can reduce the time complexity by kind of remembering that where like if some box is previously visited and we know all the paths out of it, we can have we can remember that path, that okay, that's the path we have, and that position value is this. So at particular box, there are 2 ways to move out of that. So we will remember that value. Fine. That okay, there are 2 ways to move out of that, and we know that these are the 2 ways to move out of that. So that will be more or less like the optimization we'll have over here. So if I just submit this code, it may give you a time limit exception. I'm not sure, but this may give you a time limit exception. Let's see. But we'll optimize this. Obviously, as say like you find that this is a time limit exception is given to us. Now we'll optimize this and we'll find a better solution for this. Okay, better solution, what we will do, we'll simply remember our path values. We'll simply remember the particular values or under each box. Okay, let's start with that. See, what exactly we did here, as you can see, we had the same question over here, like the same thing I had written previously, we just had here. But just we keep a memorization, like we keep a memo with us, like this is the additional long type dp variable. Now, what this is storing, this is actually storing that once we have previously found a solution for us, we simply kept the solution for, like we simply return the solution. We didn't wait there to find the solution again. So we saved our time to remember what we actually found out. Fine. So that's slide modification helped us improve the code to like 4 ms, and you can see it's like builds 100% of the Java solutions. So that's the approach to this question. So the first approach, I said, the approach is pretty simple. You need to go in 4 directions, and you kept on going in 4 directions as long as you found a way. Fine. But once there's like 4 solutions, once we know a solution that okay, there's a step, there are this number of solutions from this particular box. So we simply kept a check for that and return that solution. So for that kind of check helped us reduce our time complexity a lot. Fine. In this kind of situations, you will not see like you can argue that this is actually breaking it in 4 parts, but this is breaking it 4 parts, but not in all the cases. In fast initial few cases, it will keep breaking, and on those boxes where the previously we don't have a value, it will keep breaking. But further, it will not break. It will simply know that okay, I have a solution like this. We can continue from here. Fine. So that's the idea behind this kind of solution. Fine. So that's we improve the code and ultimately it got accepted. So I hope I can make you understand how this particular code works for us. So thank you all for watching this video. Hope to see you soon in my next video as well.